computer. So let's see, the problem statement that we're talking about before we hit record was VMware, I think, has, even if VMware stays course and goes the Tanzu route, I think a couple of problems that is obvious to not just my audience, who primarily are typically big VMware customers, and this is the conversation that I've had as they thought about whether or not they're going to embrace Tanzu, or if they're going to go like the OpenShift route or some other distro. And not just distro, because it's less about the distro, it's more about the ecosystem. Is Tanzu the right path to go down? Because there's vSphere support in every distribution of Kubernetes, and you can get that somewhere else. Or is there another solution? Customers are looking at EKS, Anthos, just a number of things. I've had other smart startups on, creating alternative application development platforms to OpenShift that's more Kubernetes centric. And I know the OpenShift guys will get irritated when I say OpenShift isn't Kubernetes centric. I make the argument that when I buy OpenShift, I'm buying OpenShift. It may be based on Kubernetes today, but I'm committing to OpenShift. And I want Red Hat to take care of me no matter what the underlay is, just as when they made the shift from their previous platform, whatever they want to call it, to Kubernetes, that I'm buying that, and I'm buying that opinionated system. But there's a bunch of in between. Like there's a lot of muck in between, like OpenShift and Tanzu. They're not the same thing in the sense that I'm solving the same problem. How are you guys kind of viewing that, and where you're taking me, and that traditional vCenter customer that has all of this heterogeneous environment to maintain? How are you guys helping to step in and fill some of that engineering?
Yeah. So I think the first step is, so there's on-prem where vCenter is the king, and then there's the cloud. I think you wrote a blog at some point in the last couple of weeks talking about how VMware arguably should have been the king of cloud because they're the VMs, right? They're the VM company, but there's more EC2 out there than VM instances. So any enterprise that says I'm going to go to the cloud, what my recommendation to them is, the cloud provider probably has a pretty good Kubernetes offering. You should use it, right? So if you're on Amazon, you should use EKS. Azure, you should use EKS. But then the same customer also has on-prem environments, right? So vCenter is something they have. And then we have a bunch of options, right? So as one example, we here at Rafay, we packaged a really easy to use upstream-based Kubernetes distributions, KubeADM-based. And what we've done is we've taken upstream bits and we package them fully, kind of taking care of the life cycle of Kubernetes, such that you can effectively press a button and get clusters up and have nodes and upgrades and all the things that you would do with Kubernetes, you can do with our solution. And many customers, and the reason why we took this path is because customers, I'll give you an example from this morning. Somebody asked me the question, so what if I need to fire Rafay here? Which is a fair question, right? Because if you don't do our job, they should be stuck. Yeah, no problem. Similar to how in AWS, we can help you spin up EKS cluster. So if you sort of fire us, it's EKS. We take our bits and go home. You got to go figure out your own automation, but it's EKS. Similarly, on premises, we use KubeADM as the core, or K3S sometimes, depending on the situation. And you just have a Kubernetes cluster left. So what we've done is we made a decision that, look, the Kubernetes distribution game is over. That was over some time ago. In fact, you and I had this conversation back in Valencia in Spain at KubeCon. EKS is one, AKS is one, and then upstream Kubernetes has one. The underlay is vSphere or EC2, whatever, right? And we're going to sell you the automation the visibility, the governance, and the operational security that you need on top of Kubernetes. That's where we built our business. Now, to the specific question you asked about, customers are looking at vCenter versus Tanzu. I think there are, like, everybody's a VMware customer, which means everybody's got vSphere. And vendors like Rafay, there are other vendors doing this also. What we have to do is we have to provide to our customers integrations and turnkey integrations where if they're in Amazon, it works with the Amazon, ecosystem. If it's on-prem vCenter, it works with the vCenter ecosystem, which means we should be able to call the vSphere API and do the things that need to happen. So that we sell today, right? So to me, VMware for on-premise is our best friend because everybody's a VMware customer. Tanzu is who we compete with, but then with Tanzu, this is my opinion. I don't work at VMware. My opinion is, I think many of my compatriots, right, other companies in the space, I think they're missing the point of what it is that customers want to do. I think what everybody thinks is that the biggest problem customers are trying to solve for is build a cluster. And they make another assumption. They make an assumption that everybody's got this massive skill set available in their companies that can solve for the policy and the blueprint and the backup and the GitOps and all these things. You're going to magically have all these people who can do all these things. And I think both of those are not true. A, I think the distribution war is over. But then B, I think the pain is more around the operationalization of Kubernetes in an enterprise, which is not the same as bringing up a cluster.
So I would agree with you. I think one of the challenges that organizations are facing is this talent gap, and it's exacerbated. I had a conversation about ransomware, and someone relayed a story to me that said a VP of infrastructure asked if Linux machines are susceptible to ransomware. And the person didn't laugh because that is just the level of sophistication at the enterprise level. There aren't people who know how to deploy a cluster, or even after you've deployed a cluster, doing something as simple as checking for doing a kubectl to check for the number of pods running on a specific, or a number of containers running on a pod. They don't know how to do that. Like, that's not a thing that they do. I typically go to vCenter, and vCenter tells me what VMs are running on each node. And that's the level. And then I go off and do backup policy and do the things that people hired me to do. So when I initially looked at Kubernetes, this was a few years ago, actually, I'm looking at it was, I was an early Kubernetes denier. Not that Kubernetes doesn't do what it says it does, but that the complexity to deploy Kubernetes in an enterprise was too much, for it to be accepted at scale. And I think I'm still right. I think for it to be accepted at scale, the talent isn't there to do it. Number one problem in my opinion. So I guess the question is, how are you solving that problem? Because it is, and it's not a dig, it's just complex. It is what it is, it's complex.
Yeah, look, I think this has happened again and again in the industry, I'm sure. I mean, when we spoke in Valencia, I was talking about, my favorite platform in the world, which is vCenter, right? I think vCenter is awesome. And we sort of see vCenter as this simple tool that solves for VMs, but actually it solves for VMs and access and networking and storage and all these other things that you need to have, work well.
Super complicated. Yeah, it
SDDC
hides a lot of complexity, but it is super complex what it does.
See, that's the thing, right? It addresses the complexity so that enterprises don't have to have an army to solve each of these problems.
Every time I provision storage, every time I provision new storage, it is very straightforward. I right click, go to provision new storage to my vCenter. All of my nodes see it. That whole activity is like super complex. Like every ESI host has to be given access control to the storage. It has to be given the path to the storage. The virtual LUNs have to be assigned. There's a whole lot of stuff going on the background, so complex. But for the vAdmin, I don't need a storage admin anymore. I can just, once my storage array is deployed, I can do this with a couple of button clicks. That's where we're at on the vCenter side of the equation. So as we introduce Kubernetes to these same folks, that level of automation isn't there mostly.
Yeah, so let's talk about, see, this is the perspective, right? Why aren't there tools that can be used by kubeadmins? You said VM admins. Right? So why is there not a kubeadmin? Right? A kubeadmin doesn't exist because there isn't one person who can do this job for the most part in tools like Tom's, right? You need many, many people, right? And this was our premise when we started working on the platform. When we were raising a Series A, Keith and I would tell VCs the story, right? I would say, look, we're gonna solve these 8 problems or crazy things, right? And they would say, no, this is not possible. This is crazy. This is never gonna happen. Go away, right? It was really hard to raise money. And then, of course, we built it, right? And if you'll allow me 5 minutes, I'll actually show you a quick demo, just to kind of give you a sense of what's possible. And you ask about architecture. I'll also show you, and I wanted to show a picture of the architecture. It's a very different way of thinking about the problem that allows us to scale that really good. Now we built it, now it's actually easier, right? We had this idea of sort of building a vCenter all over, right? And you said it, VM admin. We want to make the kubeadmin successful. That's the job, right? Now, whether they're building an EKS cluster or an AKS cluster or an on-prem kubeadmin-based cluster on top of vCenter, they shouldn't have to understand or care about the underlying complexity. It should just happen, right? And I would posit that we have accomplished that at Rafay, right?
So
you want to?
I think a good way to kind of continue is just see it, like
Sure. So let me do 2 things then. And please stop me or direct me or push me in any direction you want. I'll show just a architecture diagram, high level. Where does Rafay live in the world?
Yep.
And then we'll just go in. Yeah. By the way, our documentation is all open. Everything we do is open in terms of how we built it, what we built. And in fact, soon enough, we're also going to put our roadmap on the internet. We're so far ahead, it doesn't matter anymore. So a key thing we've done here, I'm going to a page called ZTAA, Zero Trust Kubekernel Access. We built essentially a proxy. So many of the team members here have a proxy background. They kind of see proxy in everything. The way we run our product on the internet is, so there's a green box in the middle. This is a Rafay controller. It's a single box, but it's actually a very complex microservices-based application that's running on EKS. So we run our application on Kubernetes, right? It runs in multiple regions. So it's a highly available system. We run it across 3 regions right now, and actually 3 AZs, 3 regions. This service is what all of my customers' clusters are reaching out to. So all of my customer clusters, each customer will have many, many clusters. They all are running and operating them. Whether this cluster is provisioned by Rafay or not, it doesn't matter. They're running an operator. And this operator is basically reaching out to Rafay. Now, on the other side, users, systems, whatever, right, they need to connect to the cluster. Traditionally, the way kubectl works is, you do this, right? Connect to the kube API. You don't want the customer to do that because exposing the kube API on the internet is a problem, right? That's a security issue. But then people end up deploying VPNs and jump hosts and the standard things, right? But then let's say you have a VPC per customer. Make it more interesting. Most enterprises have a AWS account per internal team, right? Mm-hmm. So let's say you have 100 internal teams. Each has a dev account and a product account. How many AWS accounts do you have? 200. How many jump hosts do you have? 200, right? You're going to need a spreadsheet to figure out where to go. That's just crazy. But in our world, what happens is a user or a system, when they need to interact with a Kubernetes cluster, they think they talk to the cluster directly. Actually, unbeknownst to them, we run a number of proxies on the internet. These orange boxes, these are highly available. They're spread all over the internet. They are actually the endpoint that your kubectl commands hit, or your kube API calls hit. And then we authenticate you, authorize you. And once we know who you are, we connect the cluster this way. This is software-defined perimeter, SDP, the security concept, applied to Kubernetes. So the beauty of this is, yes, it makes it simple, no VPNs or no jump hosts. That's the immediate effect. But the benefit of this is now we can actually take a lot of the control that happens inside the cluster and make it central. So the auth is happening outside, it's not happening inside. In fact, the service account is also being created outside, not inside. So a lot of the, the OIDC overhead and whatnot, DEX, these things don't have to happen anymore. It's all happening outside of the cluster. Everything is happening centrally. So instantly, the enterprise gets central management and control over all of the clusters. These clusters can be in the telco network, in AWS, in Azure, on-prem, at the edge, doesn't really matter. Single pane of glass, you see everything out of the box.
So if I'm an auditor, I'm going to ask, if I'm the auditor, every auditor may not ask this, but if I'm the auditor, I'm going to ask, you know what, give me traceback from when a kubectl command was issued on the proxy and under Keith's name, Keith's the security object, and it happened on the actual cluster. How do I do that traceability all the way back to the ID that performed the action on? And it doesn't even have to be the ID, the instance. How do I log what Keith has done all the way down to the actual instance on the physical or virtual host?
I'm showing it to you right now on the screen. So in the last hour, I don't know who this guy. Okay, well, I'm just one of our support engineers. What has this guy done across all the clusters, or one of the clusters, or what are the commands that he started at the kubectl level, centrally audited across all of my clusters in a single pane of glass? Out of the box, this happens. This is a side effect, by the way. This is a side effect of the architecture, that all its audit is now central. Every enterprise needs it. It just happens.
So then I can just trace back. I'm sure that there's some type of event ID I can correlate to what happened on the physical cluster.
Yes, sir.
All right.
Yeah.
So
this is rock solid, right? So now
yeah,
developers.
That's pretty straightforward. That's how a proxy works.
Yeah, the developers will do. See, developers don't care, right? This is not my problem. I'm gonna just download my kubeconfig. I can do this from an API. I'm just showing a UI because it's just a better demo. I'm gonna download my kubeconfig. I'll do what I need to do, right? I don't care. I got my kubeconfig. I can hit any of these clusters anywhere. Any of these clusters anywhere, right? And I do my job. But as the admin, I get to see everything. Right? So that's the core proxy. But now that you have a proxy, as you know, the beauty of proxies is you can overload anything. Now it's a proxy, right? You sort of have control. So then we said, well, what else can we do? Right? So on this proxy, we can provision infrastructure. So by the way, this is a multi-tenant system in that, of course, it's SaaS, so we have multi-tenant system. But then each of my customers, I'm logged in as an organizational admin into one account, right? To one company. This company is running 11 EKS clusters and like 8 on-prem clusters, and they have a guest cluster. They have a bunch of different things going on. This is a typical enterprise, right? They got all kinds of clusters. But then this company has 47 different teams running inside the company. Some of these guys are running 2 clusters. Somebody's running 1. Somebody's sharing a cluster. So if I go see my buddy Benny doesn't care that there's 20 whatever clusters in the company. He cares about the fact that his team has 2 clusters. One of them has a problem right now. So there's visibility. Now it's a proxy, right? You can see everything in one place. So now when Benny logs in, because of his identity is different from Hasib, he's going to see a different view. His view is this. Now he can go interact with his clusters. He can see what's going on them. Let's go to the one cluster that's working. Okay, I can see what's inside the cluster. In fact, I can jump into the cluster and I can see all the pods running this cluster. Again, everything single pane of glass, right? Again, it's a proxy. right? So visibility comes really naturally, it should, right? And you can see a whole lot of information inside this cluster. By the way, not only this, you can, and it's going to pop up momentarily, you can, let me find a cluster that actually has been upgraded in the past. Again, it's a proxy, right? So you can do a lot of things. You can upgrade clusters. That's an EKS cluster. I can just press a button and I can upgrade a cluster. So we still haven't really talked about a whole lot of kind of the cool things the product does, but these are the things that people spend time on, right? You upgrade clusters, just press a button, man. You want to update the AMI, press a button.
Right? I can imagine, since I'm using a proxy, I can do a ton of things. I can do some A/B testing. I can do some canary deployments. I can do all kinds of things that in theory that a proxy should enable me to do, because I'm putting a abstraction layer in between the container admin and kube admin and the lower layer piece. So in theory, yep. I should have some vCenter like functionality. Let's talk about, what we do in vCenter every day, all day, which is, the concept of a vMotion, but I don't need vMotion in the same sense that I need it for containers that I needed in the VMware world. I need to transfer not necessarily storage, compute, and memory. I need to transfer processes and applications, let's say from on-prem to the public cloud, or yep. from the public cloud to on-prem. A sticky thing happens even with Kubernetes. We say Kubernetes is easy. Yes, it's easy when everyone does it exactly the same. When I need to deploy, when I need to expose public IPs in vCenter, that's different than when I need to expose public IPs in EKS. It is two completely, the underlay is different. So yep. in theory, if I had a shim or a proxy in between the two solutions, the kube admin can move workloads or environments from on-prem to the public cloud without the kube admin understanding how to plumb any of that stuff. That's yep. theory. Yep. So in practice, how do you guys do that type of stuff in practice?
Yeah. So we've rethought what a stack looks like. So in our world, there's Kubernetes, then there's add-ons that run on top of Kubernetes. One of them would be a load balancer, by the way, and then there's the application. So we want the application to not actually care about the add-ons. And the reason why we did that is because if it's on-prem, maybe you want to use MetalLB. But in the cloud, in AWS, you're going to use ELB, right? But as an application developer, I don't care.
Right.
Right? So as an application developer, I want to deploy an app, right? We call it a workload. So I can deploy an app called, do I have one on my GitHub? I do. I see it is there right there. So I can deploy an app. And so we came up with this concept called placement. So I can say, I want to deploy an application to, actually give you a real example. So I want to deploy an application to a label. And the label is, this is a good one. Okay. EKS 1.21. If you're running EKS 1.21, deploy. I don't have any other word. So here's what's going to happen. Rafay runs a reconciliation loop. Drift. So if it finds at some point in the future that some cluster has this label, it's going to auto deploy the application to that label. You don't have to go back and do it.
That makes it invisible to the developer, which is the ideal state of Kubernetes. To say that, I want to deploy it to a label, and then there's the kube admin that worries about connecting the labels to the environment. That's somebody else's job. Yep. And I think that's the thing that I wanted to get into, the somebody else's job. Let me give you some background. We did a nice size report on the different VMware cloud options. So VMware Cloud in OCI, or VMware vSphere in OCI, VMware Cloud on AWS, VMware Cloud Engine, and Google Compute Engine. vSphere underneath in all of them. The delta is, so when I'm in vCenter, everything works like vCenter should work. Like if I need to do a snapshot of a VM, I right click, do a snapshot of the VM. what happens underneath in the underlay is magical. However, if I'm the V admin and I want to make if I want to create a new network and that new network has a public IP address, how I do that in Google versus Oracle versus AWS versus Microsoft, there's two different ways to do it in each platform, and I have to know each way.
Yeah, yeah. I would argue that maybe instead of trying to find a way to solve them all with one ring to rule them all, maybe we should just concede that there will be different options, right?
Yes.
But then make sure that there are need to know it and there are people who don't, right? So the infrastructure layer, right? Those people need to know. The infrastructure engineers need to know, right? So as an example, like if you're in AWS, you're going to need to deploy an external DNS engine. You're probably going to need, I'm sure I'm going to running an ELB here somewhere. Like you need a cert manager. You need some things that are specific to AWS. But then if you're running on-prem, maybe you need Nginx or MetalLB or some variation thereof, right? So what should happen is, and this is how we can approach the problem, we created this concept called blueprints. So the idea is that I have a standard blueprint, go to an environment which is more stuff going on. I'll go to a different team called default, they have many things. So I have an EKS blueprint, and I have a, I don't know, AKS blueprint, and then I have an on-prem blueprint, right? So somebody in the team, which is a central organization, like a center of excellence team, they're going to say that for my EKS blueprint, I must have cert manager, ALB ingress controller, CloudWatch, and cert, whatever that is, ALB controllers, these things. But then if I'm on premises, I must have MetalLB and Nginx is the controller. When I provision my infrastructure, my cluster, I should just consume this blueprint, and then I don't care, right? So the idea is that if we can create this model where there's separation of duties, some people come and set a policy. My blueprint should be X, Y, and Z. But then when I provision a cluster, I can pick. So I can say my blueprint should be whatever, X, right? And I want to use the EKS blueprint. And then I don't care. All I care about is I need a cluster. I want self-service. So my IT organization is giving me self-service options. By the way, I'm using the UI for this. Most people don't do this in the UI. They do this from like GitOps at this point, and I'm happy to show you that also. But then the blueprint determines the underlying vagaries, right? So it takes care of the vagaries of the underlying cloud or on-prem environment, but that is not the problem of the guy or gal who needs the cluster so that they can deploy their application, right? And I think that, go ahead, sir.
I'm sorry. So so this is pretty cool. So if I have a scenario, it enables like a lot of scenarios that we talk about in Kubernetes, but someone has to have the knowledge to kind of stitch it all together. So an example would be, I have a development team and I have a production team. The development team writes applications based on what the to be intended state will be. And I present to them the Rafay platform as their Kubernetes cluster. They can have very similar labels as to the production team's capabilities. But that underlying infrastructure, as the kube admin, that underlying infrastructure is plumbed to VMware vSphere or VMware vCenter resources. That same team can then move it over to, let's say, a SRE or production to deploy, and they have a very similar set of labels in Rafay, and maybe they're just changing one letter in the label or whatever, but they're using the same Terraform, they're using the same deployment and management things to deploy. It's just, and it all looks the same. The only difference may be the labels that I'm sending the application to.
Yeah, exactly. In fact, I'll show you an example of a spec file that you can use to provision infrastructure clusters. I'll use EKS as an example, then we can go look at anything also. GitOps example. So here's a file that represents a cluster. In this file, first I define, like, where it says project. Right? So this is like dev, QA, prod, China, US, whatever, right? So it's an isolation boundary. And depending on the isolation boundary, either depending on your roles in the company, either you can see it or you can. And then I'm saying I need a blueprint. In this case, it's default, but it could be anything of certain version, right? And the point here is when this cluster is provisioned, yes, it's going to be an EKS cluster, but EKS doesn't mean anything, right? Just a cluster, it needs to have a personality, right? So then give it a certain personality, deploy these 20 things on it, et cetera, et cetera. And oh, by the way, then set up a certain number of node groups. This file is a very simple way to manage things because the way we built Rafay is that, so I talked about Zero Trust before, another core component in the platform is it's actually built around GitOps. So if my customer wants to use Argo or Flux, that's okay, right? I mean, this is an open system, you can do anything you want. But this platform actually is built on GitOps. So we have GitOps pipelines built into the product. You don't need to go buy another product for this. If you don't want to. If you want it, it's great, right? And the reason why we say, look, here's one good reason why you could use our product. A, it's multi-stage. But B, two reasons. One is you can actually run your Terraform jobs from Rafay. And you can pull your Terraform jobs from Git, number one.
Yeah, so if you're at the beginning stages of adopting,
I don't even have a cluster.
Yeah, if you're at the beginning stages of adopting Kubernetes, if you're very early, then you can use these workflows and then expand them out to as far as you want to go.
Yep.
Or if you already have workflows, so if you're already a huge Terraform shop and you've built some stuff around there, you just reverse it.
Just bring them over.
Yep.
You're bring them over from wherever you are.
Yep. Yeah, you're plugging in from there.
Now here's a really nice thing we built here. So from Git to the system, right? So in my Git repo, I have some stuff sitting, and I want to create an environment for one of my new team members. Okay, so we have automation where you can basically create an entire landing zone for a team and say, hey, this team, they need clusters, they need blueprints, whatever, right? In this specific branch, let's say team new one, right? So go to this branch, team new one, under paths, Keith. So Keith is part of this team called new one, and he's going to build clusters and blueprints as Keith is putting together his cluster specs. So you're going to write a cluster spec, which is this file. You're going to check it in. It's not going to get approved yet. Your pull request is sitting there. Somebody else who's the infrastructure admin is going to approve your pull request. And the instant the pull request is approved, Rafay is going to find that. And Rafay is going to start provisioning clusters for you with the right blueprint. And potentially, if the labels are set up already, with the right application. A single file can generate an entire environment because it's Git-based.
That's one use case. Let's say that I want to be the internal service provider of service providers. So I want to give, and this is the appeal, I think, of the idea of Tanzu to an extent, is to say that, you know what, we'll just give, I'm worried about resources, like finite resources. I want people to go in and say, I want to provision 5 clusters. I want to provision 2 clusters. I want auto scaling, but I want to put some boundaries around it. But I want it to look like there's infinite resources, but there's not infinite resources. When they do, when they request resources, they'll get a return that it was denied or whatever. Just like in AWS, if I go provision something that's not available to me, I'm going to get a return to errors. So I want to be that type of provider to my internal service provider.
Yeah, we've thought through that. So we have a concept called templates in our product, where you can literally set ground rules. So you can say, let's say there's a template for QA, which says, I'm using this EKS as an example, but applies anywhere. You can only deploy using this IAM role, and you can't override it. You can only be in London, can't override it. I will allow you maybe 2 versions of Kubernetes, 1.21 and 1.22. I will allow you to only use a specific blueprint standard, and you can't change it. And we want. Now go build a cluster. So you can actually lock people down in a certain environment. And you can do way more than that, by the way. You can say, for example, you can only use a certain VPC, you can only use certain node groups, you can only use certain instance types. So you can actually make it such that a developer comes and says, hey, I need a QA, I'm in QA, because they are in QA, their role is QA, which means they can only go to a certain template and they can only spin up a cluster with one node or whatever you decide, right? You can lock it down to that extent, or you can open it up to whatever you want. But
So
now you can do true self-service.
So I guess the end to kind of begin to wrap up is, what does this do that a Tanzu or Anthos or these platforms that want to be, because all of them advertise the same thing with the exception of maybe AKS, EKS, they acknowledge that there's other, Kubernetes clusters somewhere else and they would run it. Whereas Google and VMware absolutely embrace that there's other Kubernetes clusters, and you either have the Tanzu abstraction layer or you have the Anthos abstraction layer. Where does this kind of make opinions or offer stuff that the other solutions don't?
So I think the market is going in, all of us are going in the same direction fundamentally, right? Which is our customers need 7, 8, 9, 10 different things solved in one platform, because it just the problem is too complex, right? So on this call today, we've been focused on infrastructure, right? Which is an important piece, but it's one piece of it, right? Other things that matter. Everybody wants to deploy gatekeeper policies, right? Everybody. So we built a native integration where you tell me I need a gatekeeper policy, and then the underlying gatekeeper configuration, the admission controller match. You want to do backup and restore? Tell me I want to back up a node or a cluster, and only the control plane or VPCs. We will take care of everything. You want to deploy applications? We have a GitOps model. We take care of everything. You want to do secrets management? We've already built it. You want to do data aggregation? We've already built it. You want to integrate registry so you don't have to share your full secrets with every developer? We built it. You want chargebacks? We built it. You want a catalog? We built it. The point is that I think this team here at Rafay, we fundamentally understand the roadmap of our DevOps team, right? And what else is coming, right? So we're working on network policy management, service mesh management, right? Each and everything that my DevOps customer has to deal with inside the company, I want to deliver to them as a quote unquote service that is built into this platform. So they don't need to go buy yet another product and integrate. It's my job. It's not their job.
So right? That's pretty ambitious.
Yes, it is. Yeah, totally.
I was talking about Valencia, I was on the bus ride in Munich from one terminal to the other. And I was listening to this guy who worked for one of the agencies, the EU agencies, and he was telling one of the other attendees how they're headed to their third service mesh because the other two were too complicated. And I think, and my guess, after talking to a bunch of service mesh people, my guess isn't that the service mesh itself wasn't too complicated. It was their ability to operationalize either of the two and getting the data that they need. So as you think about all the things that a service mesh does, if you think about all the things that a messaging service does, or all the different components that, that CNCF chart is big for a reason. And the thing that vCenter does well is that I can change a lot of stuff in vCenter if I want to, but 98% of customers probably should.
Exactly right.
Yeah, there's
exactly right. See, that's exactly the right approach, right? So what we do is, as an example, right? So most of the enterprise customers we talk to, they use HashiCorp Vault. So we have a first-class integration with Vault. You want to bring in something else, we support that too. That's a little bit more. But we take one or two options and we just knock them out, right? We just make it perfect, right? And we've done this again and again and again. Look, you said this is ambitious. This is a crazy plan, Keith. It's not ambitious, it's crazy, but it turns out that this is the crazy team to make it happen. We've done it, right? It's not a story. It's a product. It works. It's got
it's my complaint. It's what I've been complaining about for the past 5 years about Kubernetes. It is, for better or worse, the enterprise has high expectations about what this type of production workload looks like. I think people have underestimated the transition or the journey to cloud native. We cut our teeth, we hit our heads up against a lot of these problems early in the build out of like our industry has grown up during the VM world, and we've solved a lot of problems during that time period. And now we have to solve the same problems again. And that tribal knowledge has been lost to an extent, or that tribal knowledge to do and build, or the patience, or the governance and acceptance of the time that it takes to rebuild a lot of this stuff. So when a person like me looks at Kubernetes and looks at the work that needs to be done in an enterprise IT team to get there, I'm like, where's the horses? How do I get there? That's a lot of talent that I don't have. And if I had it, I'd probably have them solving different problems.
They'd be working on something else. Look, there's so much to do here. And I mean, look, we knew this was going to be a crazy plan. We had to hunker down for a long time to get this right. And we have a few minutes left on this conversation. So I'll share one example of something that is actually relatively trivial, but it's important to think about, right? So let's say you have a registry that all your developers use. So the way your cluster will talk to the registry is there's something called a pull secret. So you need a secret to talk to the registry so you can pull a container. The traditional model is you take the secret and you put it into a YAML file, and that's then you push YAML. So now the problem with that is the YAML file is sitting where? It's sitting in a Git repo, right? So your secrets are not sitting in a Git repo. And that's a problem. So what people do is they say, well, okay, maybe we should solve that problem by encrypting the secret. And what if we could provide a way where, remember, we are a proxy, right? We could provide a reference to the registry, and because we have a proxy, we could change the value when the file hits the cluster. So don't ever expose the pull secret to your developers. We, Rafay, have built a model because, again, we have a proxy. We can do all of these things. We will change the value while the file is going through the proxy to the cluster. So we built a model for that. This is a small example of the work we've done here. And this is what it takes to build an enterprise product, right? Enterprises care about this stuff.
That actually introduces another thing. As I think about HashiCorp Vault and what happens when I use a proxy to access multiple clusters, where that also creates an opportunity is to have roles that can transcend cloud environments. So like in AWS, I can assign a role to a pod or application, and IAM gives me the ability to kind of do some super powerful things, but that's only within the boundary of AWS. So if I have a proxy that's accessing all of my clusters on my behalf, in theory, I can create roles that transcend all of my clusters across different infrastructures.
Yes, sir, you can, and we have. So look, I'm logged in as a guy named Hasib. This is an on-prem cluster. Well, this is a Kubernetes cluster. This is an on-prem cluster. I'm going to kubectl into this cluster and do what I need to do. Okay, boom, right? And then when I look at my service account is my identity in this cluster, right? Hasib's service account was created 9 seconds ago. Didn't exist. It got created right now. Now I'm going to do the same thing with the on-prem cluster. This would be a little bit slower than any little cluster. And I'll do this the first time, and boom, that was fast. Service account minus n, system. Hasib's identity was created 10 seconds ago. I went to 2 different clusters, and my identity was created just in time and inserted into these clusters. One's an EKS cluster, one's on premises. Why does it matter? Because we have a proxy. This is the beauty of this model. This is why I'm so convinced that we have the right answer for this market. We have really thought, I say we is unfair. My colleagues, I'm just a small guy, my colleagues have done a really good job here, right? They've really, I mean, they've nailed the problem, right? This is as a developer, if I have to now rethink my strategy when I go to the on-prem cluster versus EKS versus AKS, that is burden on me as a developer. I don't care. I want to write my app. I want to debug my app. I want to move on. And look, when I did these 2 kubectls, could you tell the difference? Was there any difference? It's the exact same experience because there's a proxy in the middle. And that applies everywhere, be it registry pull secrets, GitOps, kubectl, application deployment, it doesn't matter. We've really thought about how to make it the same experience while at the same time not obviating the need for the infrastructure, changes, right? EKS will have ALB and on-prem will have LLB. That is not my problem. That's somebody else's problem. They'll manage that. I'll manage my app. Separation of duties while at the same time getting the best out of each platform. That's the solution that seems like we have built here.
All right, sir. Well, I appreciate you taking the time out.
Thanks, Keith.